Evening, Professor Oldfield.
Good evening. I'm Professor Rupert Oldfield. I'm Professor of Astrophysics here at the university, and I'll be presenting this new episode of 61 Symbols. So today we'll be examining the domino. The domino is a small wooden block of approximately 4 inches in length, and it makes for a fantastic parlor game. Well, it's nearly tea time. Would you look at that?
Professor Rumford here from the University of Nottingham. Now here we have a series of dominoes. Now with the dominoes are lined up like so. 1, 2, 3, 4. Professor Gibbons, could you please pass me another domino?
Certainly.
Thank you, sir. Okay, so we have two more. Okay, so you line up the dominoes like so. And the dominoes clearly are not going to fall by themselves. But you push one of the dominoes, and the effect is that all of the dominoes fall at once.
Hello, I'm Professor Gibbons, and I thought I'd talk a little bit about the transfer of kinetic energy into potential energy and back into kinetic energy that occurs in kind of the domino chain that Professor Rumsford talked about before. And so if we take a look at this diagram here, you can see that the potential energy of the domino is given by the height of its center of mass. And so as soon as this domino is knocked over, you can see that as it falls, the center of mass will also fall. And this change in height that you see here will cause a change in potential energy. When this change in potential energy occurs due to the law of conservation of energy, this potential energy must go somewhere. It must be converted into some other form of energy. And so what happens is that it is of course transformed into kinetic energy. And as it falls, it gains speed according to this equation right here. Kinetic energy is 1/2 the mass times the velocity squared. And as you can see, as it falls, really, the change in height in the center of mass really isn't that much at all. I mean, as you can see here, compared to the actual height of the domino itself, the change in height of the center of mass is really very small. And so because of this, the change in potential energy is very small as well. And as a result, so is the kinetic energy that it has. And so because of this phenomenon, we can see that the kinetic energy that is transferred into the next domino by the falling domino is really just enough to release the potential energy of the following domino. And so it's not really that the energy that the initial domino is given is really transferred through the chain of dominoes, but rather it's enough energy to kind of release the potential energy that is already contained within those sets of dominoes.
Okay, so here we have another set of dominoes. And so the common misconception is the initial kinetic energy supplied to this domino is transferred throughout each of the dominoes, and that kinetic energy is equal to the kinetic energy of the last domino falling. When in reality what happens, so each of these dominoes has a stored potential energy determined by its height, and its gravitational potential energy equals mgh is equal to 1/2 the total height of because it's the center of mass of the dominoes. I won't get into that. Anyways, so there's a stored potential energy in each of these dominoes, and so when you apply a kinetic energy, it releases that potential energy of the first domino, and so the first domino begins to fall, and so its potential energy is converted into its potential energy is converted into the kinetic energy, which releases the potential energy of this domino, which causes this domino to fall, turning into kinetic energy, and so this kinetic energy releases the potential energy of this domino, and it's a sequential chain of reaction. And so as you'll see, the tiniest tap, a small amount of kinetic energy, because there's stored potential energy across all these dominoes, will cause a much greater energy than the initial kinetic energy. So you'll see in this reaction, all of the dominoes falling is at an energy much higher than the initial kinetic energy of the domino.
Professor Oldfield here again. So that's all from here, but we'd like to show you we received a video response from a group of physics students in the US of A. And strangely, they kind of resemble our crew here at the laboratory, but go ahead and take a look.
Alright, so this is our domino track. It's supposed to demonstrate the transfer of potential energy into kinetic energy, and we have a lot of different examples of that in our track. The track starts over here, then it's going to follow a bunch of kind of switch tracks. Then it's going to continue on through this little loop, and then gain potential energy up on this set of stairs, knock over kind of a set of bricks that's going to continue the chain, hit another few switches, and then knock over a marble that'll knock over some more dominoes and finish up the domino track by destroying that big wooden tower over there. So yeah, here we go.
Alright, please work.
Yep.
Please work. Please work.
3, 2,
Straight on.
1.
Oh!